The second statement. Question: which statement is true? The rate of change of substance is twice the magnitude as the rate of change of substance. They are talking about this reaction. So take red. Is red the twice? So it is the twice of, yes, we have 1 2 3 green, and 1 2 3 4 5 6 red. So 3 times 2 makes 6. So red are obviously twice of green. So I think the correct option here is the A1, because they have said that which statement is true. So A1 is true. If they would have said that which statements are true, then you have to look into the other statements. But you can see is equal to the red. No. Is twice the magnitude. No. D1 blue is equal in magnitude, that opposite in sign to rate of change. No, never, because the reaction is here only in the progress, in the forward direction, and the red blue arises from the left side, and green has no relation. The red and blue and green, all of them arise from the left side of the reaction in the forward reaction, and the blue one has no correlation with the green one or red one. It is the only reactant for the products blue and red. It is the only reactant for the products green and red. Alright, that is just a confusion. So the answer: the rate of change is determined by the change in concentration of the substance divided by the change in time. And A is true in the first 15-second time, and turnover time is as much of that is formed then. So therefore change in molar concentration of the red one by 15 seconds will be twice as big as change in the molar concentration of the green one divided by 15 seconds. Moving towards the next question, in which they says if each colored image represents 0.10 molar. Just note the concentration, that it is 0.10 molar of the substance, then determine the rate. So in this question we have to find out the rate. What's the rate in this case? Alright, in meter per second. What's the rate in meter per second of change of substance over the first 15 seconds? So the question is asked during the reaction in which this is converting to this one. It is not mentioned in the question number 2. Alright, it is in question number 3. It is asked in question number 3. This is crossed, and this reaction has been mentioned and a question is asked. So progressing towards the answer, the rate of change for a substance is determined. The substance is the blue one at 15 seconds minus blue at 0 seconds divided by 15 seconds. So remember, each blue is equal to 0.10 molar. Therefore the rate of change of blue will always be equal to 0.4 minus 0.8 divided by 15 seconds. So it will equal minus 0.027, which is the answer to the question number 3. If you have any problem in this question, you can mention in comment section. Now in kinetics, we have to compare rate of change for reactants and products both. In the first questions or in the first problems, we just compare the rate for change for reactants but not products. Now you have to compare reactants and products both. Let us say we have a question in which consider the following reaction in which we have 2 sodium pentoxide changes to 2 moles of sodium earth oxide in gaseous form plus oxygen gas. The overall reaction here is in gaseous phase, and there is 2 moles being converted to 3 moles, so there is no formality, only molarity. If at some point during the reaction the rate of disappearance of ammonium pentoxide is 0.15 meter per second, what is the rate of appearance of oxygen gas? Then the reaction given in the problem or in this problem, their rate negative change in concentration sodium pentoxide divided by 2 del T equals del N2O4 divided by 2 del T equals del O2, mean oxygen gases form divided by del T. So the term rate of disappearance of sodium pentoxide is represented by negative change of concentration of sodium pentoxide divided by del T. The rate of formation of oxygen gas is represented by change in concentration, molar concentration of oxygen gas divided by change in time. Then use only the portion of the expression that is required for this problem. For solving the question, we are asked for the rate of disappearance of sodium pentoxide. Alright, then the rate of appearance of oxygen has been asked in this process. So we have to mention the expression that is only for concerning the problem. Alright, so moving towards our section, that is minus change in concentration of sodium pentoxide divided by 2 del T, which equals change in concentration of oxygen divided by del T. Then putting the value in the above for the rate of disappearance of sodium oxide and solving for that portion or for that portion of the reaction. Alright, we have to solve for this portion. Then solving, putting values sodium pentoxide and the time given, we will get 0.075 meter per second as the rate of appearance of change of concentration of oxygen gas divided by change in time. Now let us consider the next question. Consider the following reaction. The reaction is in terms of ammonia gas, in which 5 moles of oxygen has been added. We have 4 moles of sodium oxide and 6 moles of water. Okay, at some point during the reaction, the rate of appearance of sodium oxide in here is 0.100 meter per second. What is the rate of disappearance of oxygen gas at the same point in the reaction? When we get this point in which sodium oxide has this rate, what will be the rate of disappearance of oxygen gas at the same point in the same reaction? Alright, so mentioning the answer for the reaction given in the problem, we have rate change in concentration of ammonia divided by 4 del T equal change in concentration of oxygen gas divided by 5 del T, which equals nitrogen gas and H2O divided by change in time respectively. So the term rate of appearance for nitrogen oxide is represented by 4 nitrogen oxide divided by change in time. Thus the rate of disappearance of oxygen gas is represented by that formula. Then putting the given information for the rate of appearance of nitrogen gas and solving for change in molar concentration of oxygen gas divided by change in time for the reaction to happen. Afterwards, the change in molar concentration of oxygen gas divided by 5 del T, putting values on the right side of the equation. 0.0100, which is the rate of disappearance of ammonia in the reaction, divided by 4 is time required for disappearance of ammonia in the same reaction at a particular point. So multiplying 5 on both sides, we will get a value like this, and the overall result will be, or the overall answer will be this one. Alright, this is the answer to the rate of disappearance of oxygen gas in the reaction at a particular instant of time or at a particular point in the reaction. In terms of another equation mentioning the kinetic rate law, we have hydrogen gas and sodium oxide making sodium gas and H2O water, and the rate of the reaction is likewise H2 concentration times nitrogen oxide concentration. Which of the following statements are false, wrong? So the reaction is third order reaction, that is correct. The reaction is second order reaction in terms of H2, wrong. The reaction is second order NNO, yes. The reaction is first order in terms of H2O, that is also wrong. So the statements being wrong in here are the B1 and the first D1. But in the overall question, the reaction true for the question is the B1 and the D1. But relating to the sense, the reaction is second order NH2, the reaction is first order NH2O. These both statements are wrong. The B and the D are wrong. Alright. The remaining detail for the question. Also, if you can ask for any comments on a video, you can tell me. I will make another video on the detailed explanation to the question. Second question, in which you have the rate law of the reaction like this. And what will be the effect on the rate of the reaction if the concentration of both hydrogen gas and nitrogen oxide are doubled? If the concentration doubled, what will be effect on rate of the reaction? Then answer: one way to determine the effect of concentration changes on the rate is to do two separate calculations. In the second calculation, you use twice the concentration of the two reactions used in the first calculation. The example below: 1 molar concentration was used in the first calculation, 2 molar was used for the second calculation. You can see the detail of the overall those statement or those explanations given in here in mathematical form. So you can see the answer is mentioned if you can guess for it. Therefore, if the concentration of each substance are doubled, each substance concentration is twice, 2 times, the rate is increased by a factor of 8. Alright, which you can see in this statement, the rate is 8 times and the concentration of each substance are doubled. Alright, now relating kinetics to the Arrhenius equation, the rate constant for the decomposition of a certain substance, which may be acid or base or any species, were measured at 5 different temperatures. The data is given in the table below. Graphically determine the activation energy of the reaction in kilojoule per mole. So relating the concept of kinetics or chemical equilibriums according to Arrhenius equation. So different substances decompose at different temperatures and their rate constants are being measured, but the data is given in the table below. You can see graphically determine the activation energy of the reaction in kilojoule per mole. So they had determined the graphical energy for the first condition in terms of kilojoule per mole or Kelvin, which is the heat temperature required for the reaction. They want to give us a table for Arrhenius association of each substance, first, second, third, fourth, fifth, and in the return they ask for the activation energy in terms of kilojoule per mole. In detail, we will determine that one in detail. Moving towards our next section, a reaction has an activation energy of 245 kJ per mole, temperature 250 degrees Celsius, and the rate constant is 4.45 cos 10 to the power minus 3 per second. Calculate the rate constant at 350 degrees Celsius. Kinetic reaction mechanisms. Consider the following two-step mechanism for decomposition of hydrogen peroxide. You must remember that it is not water, it is spirit. Hydrogen peroxide, which we use for healing our wounds using a tissue paper or that dispensary material. What is this called? I don't know, but it's spared. So step 1, iodide has been reacted, making hydroxide ion and H2O water. That is a slow step reaction. If we add the same hydroxide ion which is prepared in the first step to the next step by adding the same hydrogen peroxide or spirit molecules, then we have H2O water plus oxygen gas and plus iodide ion, and the reaction overall is a very fast reaction. Then answer each of the following questions according to the above statement. Which substance or substances are intermediates? So the intermediate exactly is the hydroxide, cause it is used in the first step and in the second step both. The second question they asks is that which substance, if any, is a catalyst? So the catalyst in here, you can see in the second step that the catalyst in this reaction is also the hydroxide ion. It is intermediate being used in the second step, causing the reaction to be more faster and making more ions, oxide ions itself, oxygen gas itself, and H2O water too. So the catalyst is hydroxide ion also. What is the overall reaction? The overall reaction is very easy to mention. First of all, we will write this reaction. The H2O2 combined with plus I or negative and had made products this and this. So that will be our overall reaction, the summing off of this. So what is the Rate law? The Rate law mainly states that the change in the concentration or decomposition of each of the substances at a particular instant of time or according to time. At any instant of time, we have the Rate law stated here. So advanced chemistry practice problems. We have kinetic catalyst. Examine the following diagram depicting the potential energy diagram for the reaction. So generally the reactants has been given general reactants A plus B combined to form C plus D. Alright, when they combine they form C plus D. So we have a diagrammatic representation also that A plus B in the initiation step do not react, but when they react the reaction gets very strong, the reaction rate gets very stronger, and the curve shows that the potential energy exceeded at this point very highly, and then from this point it also gets down cause the reaction has gotten a lot extent of stability and the products had been formed in the reaction. So we have reactants combined to form products C plus D. Alright, so the reaction here is in progress. Afterwards, draw within the same diagram about the potential curve if any effective catalyst is used in the reaction. Yes, if any effective catalyst is used in this step, if at this step the reactive catalyst has been used in the curve, then the curve will be likewise. Alright, if a catalyst is used for the backward direction at this point, then we have the curve being like this, cause the reverse reaction will be favored and the overall products will be converted back to reactants in the reaction. Alright, so the second question is they describe the similarities and differences between the following: a homogeneous catalyst, a heterogeneous catalyst, and an enzyme. So what you really think of a catalyst? Catalyst is any substance that just speeds up a reaction and do not get involved in the reaction itself, or do not give its ingredients for the reaction to speed it up. Just it acts as a stabilizing agent for activation energy that lowers the activation energy of reaction and accelerates it. Homogeneous catalyst is the one which is used in homogeneous reaction. Homogeneous reaction are those reactions which occurs in the same phase. For example, reaction is occurring in gaseous state, or is it occurring in liquid state, or is it occurring in solid state. So homogeneous catalyst is used for homogeneous reaction. Heterogeneous catalyst is used in heterogeneous case, in which we have gas phase being converted to liquid, or liquid to solid, or solid to gas, or liquid to gas likewise. So the heterogeneous catalyst is used. And enzyme is a special type of catalyst which is used in mostly in metabolic reactions or biological metabolic reactions in the body of human organisms or any other organism. So that was overall explanation about reaction kinetics, mostly related to uh, different theories like the law of mass action or Arrhenius equations or examples questions. If you ask for any other methods, I can mention in my lecture, like teaching method, like practicing method, like diagrammatic method, like mind mapping method. Anything you will ask for, I will mention that in my lecture in the second phase. That's the first phase of my lecture. If you would like to cause any changes to my lectures, you can ask in the comment section. Any question, any problems, you can ask, and you can also contact me. My number is +92 320 55 84 972. Alright, you have a nice day. Thank you. Then going in more detail in the reaction kinetics, we have a lot of other applications of reaction kinetics. The reaction has been given and different time intervals are also given. Alright, so recall images that represent reactions. There may be more than one reactant. So you can see in this case there are only two reactants, A and B. Afterwards they ask which statement is true. That what is the magnitude of the change of substance. So the first statement is always true. Then comparing the rate of change of our reactants and products. So these are different kinds of numericals which should be solved according to the requirement they have asked for. Disappearance of oxygen, rate of appearance of oxygen. Alright, then we have the rate law is false. So what you think is false? I think the one that is false is the B1, cause hydrogen gas isn't second order according to the reaction equation. It is first order. You can see this power is just and only 1 in here in the overall reaction. Alright, so the wrong equation is in here is the B1. The law of the reaction is this. On the rate of the reaction, what will be the effect on the rate of the reaction if the concentration of both H2 and NO are doubled? Kinetics rate of chemical reactions. The diagram below depicts the progress of a reaction. Each shape and color also represent a different substance. The three boxes represent the concentration of each substance. As the indicated time elapses, refer to a diagram to answer questions. So recall images represent reaction. There may be more than one reactant. So obviously there are more than one reactants. You can see in here all of those colors are reactants because they are reacting and making another product. Alright, so this, all the three options are reactants in this case. Alright, the amount of reactant will decrease as the reaction progresses. Therefore answer B is the reactant mostly. Yes, if the reaction progresses, at the stage when the reaction progresses, then we have the B option is the correct because this is the only reactant that is going to progress in the overall reaction and making a lot of products in the reaction at that time and so on. Alright, then they are asking which statement is. So what do you think the correct option is? As you can see, the rate of change of substance is twice the magnitude as the rate of change of substance. That one is the correct. Alright, according to me, you can ask for if there was any mistake in there. Concentration of sun divided by the so answer A is true. Alright, in the first 15 second, time interval is twice as much as this one is formed. Then therefore change in concentration divided by time, change in time will be twice as big as change in concentration of the green one divided by change in time. Alright, if each colored image represents 0.10 molar of the substance, find out rate in meter per second of change of substance blue over the first 15 seconds. So the answer is clear. Change of substance difference divided by change in time. Alright, so we will get, remember each blue is equal to 0.10 molar. Yes, then therefore the rate of change of concentration will be, this will be our answer. Alright, the answer will be that one. Okay, kinetics comparing the rate of change for reactants and products. This reaction, if at the same point during the reaction the rate of disappearance of is this one, rate of appearance of oxygen is this one, then for the reaction given in the problem, that one and that one, comparing, we will get the term rate of disappearance of NO represented by this and that of oxygen by this. Alright, putting values in the last option, we will get the answer which is 0.075 meter per second. That is our exact answer. Alright, then we have ammonia, the same problem which we mentioned in detail in the last option, and its rate of determination accordingly of change in concentration of molar concentration of oxygen gas divided by change in time. Alright, then we have kinetics, the rate law which we mentioned in the next lecture, previous option. There are the same question asked in the previous option. Afterwards we have the second topic which is kinetics, second order kinetics. Kinetics are chemical equations which are being arranged according to kinetic law of mass action, and reactions are mostly second order reactions. So considering the data collected for the reaction in which H changes to products, we have time as, we have the mentioned values too. Afterward mentioning all of the values, we can determine the order for the reaction also. Alright, as with the first problem, Found in Module 5, First Order Kinetics and Integrated Grid Law Practice Problem. The plot in AV it can be produced. If linear, it is first order. Then natural log A versus time, in which we have 1.4, 1.2, 1, 0.8, 0.6, 0.2, etc. The plot is curved, non-linear. So whenever we have a plot that is curved like this, you can see. So the curve is being drawn from this point to this point. Alright, like this. Let me draw it more clearly on blue, which will looks like this. So it is a curve form of graph which represents that the reaction is first order, it is not second, third, or anyhow. Now produce a plot of A1 by A y with respectively. So we will do it, or if you can't, you can ask. You can see that I have the solution at different values of 1 by A. Change in molar concentration of A, which is 1 by 1 molar. So 0.1, 0.2, 0.3 providing different values where we respectively get different time intervals at 10, at 15, at 20, at 25. So a curve will also be curve in this shape, in this shape, as you can see. Alright, so it is a curve form of curve in the graph. So reaction in this case is second order, because the plot is not curve, the plot is a linear curve, you can see. But if the curve is not linear like was in this case, it will be first order, cause it is not linear, it is curve. Then we have general explanation to different problems. You can practice them. The answers are also being given in the last of each question. If you need any help, you can ask for. Thank you. Have a nice time. Goodbye.